In this video, we will learn how to find the Shapley-Shubik power index for each voter in a weighted voting system. So here's a typical problem. In the weighted voting system 14, 10, 8, 5, 2, find the Shapley-Shubik power index for each voter. First, let's try to understand some of the terminology we're going to be using. In a weighted voting system, we have a certain number of voters, which are the numbers after the colon. In this case, we have 4 voters, which have 10, 8, 5, and 2 votes respectively. And then we have a quota. The quota tells us how many votes we need to win a vote. And in this case, we're always thinking of votes as either being yes or no, voting in favor of, say, a piece of legislation, or voting no and voting against it. Typically what we do is we give the voters names in order as they're listed after the colon. So in this case, we'll have 4 voters, A, B, C, and D, where A is the voter with 10 votes, B is the voter with 8 votes, C is the voter with 5 votes, and D is the voter with 2 votes. Now notice that none of the voters can pass any legislation by themselves. They need to work together. And so what we do with the Shapley-Shubik power index is we try to measure the amount of influence or the amount of power that each voter has by looking at how they can work together with the other voters to get things to pass. The next thing we need to consider is a permutation. A permutation of the voters is just a list of the voters in some order. And there are many possible permutations. ABCD, CABD, DBAC, CDBA, and so on. The Shapley-Shubik power index relies on finding the pivotal voter of each of these permutations. To do this, first we start with all of the voters voting no. So for example, we could consider the permutation CBAD for this weighted voting system. We start with all the voters voting no. And one by one, in order, we change the vote of each voter from no to yes until there are enough yes votes to win. And the voter that tipped the scales is what we call the pivotal voter. Let's see how this works for this permutation. So we're going to start with everybody voting no, and then we'll start with C switching its vote from no to yes. But that only gives us 5 votes in favor, and the quota of 14 tells us that we need 14 votes in favor in order for this legislation to pass. So we go down the line and we say, let's change B's vote from no to yes. Now we have 5 plus 8, which is 13 votes in favor, but that's still not quite enough, so we keep going. Now we change A's vote from no to yes, and now we have 23 votes in favor, which is well more than we need to make this legislation pass. So A was the pivotal voter. A was the one who, when we changed its vote, made the legislation go from not passing to passing. Let's try this again for another permutation. Let's consider the permutation ABCD. Again, we start with all of the voters voting no, and one at a time, going in order, change their votes from no to yes until we have enough votes for the motion to pass. So we change A's vote from no to yes. Now we have 10 votes in favor, but that's not enough. Next we change B's vote from no to yes. We have 18 votes in favor. That is enough. So that means that B was the pivotal voter for this permutation. For the Shapley-Shubik power index, we'll find the pivotal voter for every possible permutation. And then what we do is we count up how many times each voter was pivotal and divide that by the total number of permutations. And that gives us the power index for each voter. So using the same process that we just did, we find the pivotal voter for each of these permutations. Those are listed here. And then we simply count how many A's, how many B's, how many C's, and how many D's we got. So the power index of A is 10 out of 24. The power index of B is 6 out of 24. The power index of C is also 6 out of 24. And then the power index of D is 2 out of 24.